Hello everyone, it's Sean. Welcome back, and we're going to just kind of jump into this one. We got ourselves a Max 200 4-power amplifier, or 250 is probably the wattage, peak wattage amplification for this product. Looks like we got 2 channels, signal, increase range 0 to, what is that? Looks like an infinity symbol. 0 to 58 at least. I don't know if that represents decibel gain or what. I haven't looked at the manual for it. Nice little tactile switches on here. It's not like your typical pots where it's just smooth. You got a little bit of a kind of an indication of the fact that you turned it. What do I call it? Like a ribbed indication. I don't know how else to put it. Anyways, online search doesn't bring back much for this other than user manual. A couple of these selling on eBay between $85 to $130. But let's take a look at the back. And here we go. Here's the back. See, what? Balanced audio XLR inputs, or phono plug. Essentially, audio plugs. Nothing too specific to write home about. Parallel or stereo audio. Floating or grounding. Our 2 outputs, minimum 4 ohm. So minimum 4 ohm speaker. Channel 1, channel 2. Probably you would use these to drive 8 ohm. Bigger, loud speakers. And then possibly the ability to 80 watts at 4 ohms. Okay, so disregard that 250 comment earlier. But anyways, looks like you could potentially strap the power supply for different mains voltages. All this right here most likely is just a little pin you pull out and stick into whichever hole after you've strapped the transformer correctly, and any other things you might have to strap correctly for the power supply to make that adjustment. But really, again, not much to write home about with this product. Serial number and cage code per se, kind of, or scan code for when you purchase the product. But the customer said no power, so we're gonna plug it in real quick and just confirm that condition. Alright, and got plugged in. Dim bulb hasn't lit up, so let's turn it on. And yeah, looks like you get a little bit of illumination out of this LED here, but nothing from here. Make this one as well. Or are my eyes playing tricks on me? Might just be a reflection of this LED light right here. Yeah, my eyes were playing tricks on me. Would you look at that? Nothing. Might look like it's glowing, but here, maybe I just turned that off. Alright, better. Yeah. Nothing. Absolutely dead. Confirmed. Not drawing a single thing, so let's get it apart. Let's take a look at it. Okay, so we got it out here on our bench, and I was just when I stuck it up here, kind of blowed out our heat sinks a bit, and we got a little friend sitting right here, or the I don't know if you could see that, the old husk of one, little spider. Call him Pete. I'm gonna stick him over there. Alright, are we going to actually, Pete, we're going to put you down on top of the magnet. Man, look at that. You just stick right to the paper right there, don't you, Pete? Anyways, so you might be asking yourself, well, if this item sells for like 80 to 100 something on eBay, why would you want to somebody to repair it, you know, why not just replace it? Well, the thing is, if you can win the auction, yes, it'd probably be cheaper in some regards to replace versus repair, but you know, when you repair, you keep a lot of e-waste out of the refuse, and e-waste is not going to break down, and it's pretty tough. Might not be able to get this off that way. Top probably doesn't come off without taking heat sinks off. I kind of don't want to do that yet, so let's we'll have to work my way around it. But anyways, e-waste is not going to break down. It's not organic material. Okay. The second thing is well, why don't you just buy a new one, right? Well, a good 2-channel amplifier like this, and again, I'm not too positive on the brand name of this one, but I would assume that most good 2-channel amplifiers are going to cost you in the range of $300 to $700 something dollars, you know, for brand new. So in some regards, yeah, it's actually a lot better to fix an item than replace it. And then obviously if you send it into a technician who has the ability to repair, you know, it's not just the repair you're looking at, but you could probably get a bit of service done as well. So we'll see what's causing the power fall, but we'll also check the input and output for this customer to make sure that the amplifier is good to go completely. Yeah. Anyways, I guess that's the plug though, because you know I do it in every video. I operate Having Fun Repairs here in the state of Oklahoma. So if you have something you want repaired, you can definitely send it to me. Check out the Google link, Google site in the description. It should take you to my business page. Those are tops. These are backs. I'll probably need to label these somewhere. And you know, we'll work out a deal for getting something repaired. Do restoration services of vintage electronics as well. What else? And of course, if you're just watching for the content and you enjoy this channel, please like and subscribe and all that jazz. And if you just want to donate to the channel for me to feed my need of buying things from eBay or broken items from old items from pawn shops and stuff like that, and fixing them up, and you know, really enjoy the content. You know, a lot of the stuff that I share with you is stuff that I purchase outright. Not a whole lot of repairs. This is actually the first repair service I've done since starting my business, although I have helped some people out in the past. But yeah, you know, all that's in the description. So let me work on getting this apart and we'll get back into it. Okay, so we got the top case off. You can already see 2 blown fuses here at least. Those 2 look like they may have gone as well. Nice beefy transformer we have in here. Yeah. All 4 of these fuses have blown. I'm going to take my ring off just in case if there's anything stored across any of these capacitors. I don't want to risk it. So we got 4 blown fuses, and traditionally speaking, fuses do not blow for absolutely no reason. And I'm kind of seeing the reason for why they're blowing. over here on the right hand side, tracing where our power comes in. Boom, got this board over here. Let's see what we got. We got our on-off switch, and you can see these burnt markings. I don't know if you can really tell that, but right off of this cable right here, 4 blown fuses here. What is that? Is that a fuse as well? Did that one blow? That's 6.3 amp, 250 volt fuse. Surprise, surprise, that one's okay. Alrighty. But these feed underneath. Like they go to this transformer, but we've got a massively blown component over here on the right hand side. What is this? What disintegrated over here? Something pretty massive. What was that? Possibly a cap? I don't know. Transistor maybe? I mean, there's the remnants of something blown. And not only did whatever was beside here blow, looks like, is this going to be a, please tell me this is not the voltage regulator board. I mean, you might have input power over here, and here's goes your main caps. But is this a low voltage power board? It is. These are probably our rectifiers. Well, it says C. Well, C is capacitors, so B. These are probably rectifiers here. But we got something super iffy that happened over here. This might be the reason for everything that blew over on the other side. Man, what is this? Is this a cap? What in the world was this that blew? I have to get this guy out and we'll take a look at it. There's no other way around it. No clue what these pieces are of whatever disintegrated. Probably not healthy to taste. But interesting. Definitely got some massive failure over here. Now, did this failure take out this over here? I do not know. Let's see if I can find some schematics or something. Oh. This is mimicked from this side to that side. So these are our amplifiers. Okay, I think I'm following more now. Heat sinks, amps. This was on the amp side. And if I look at what's occurring here versus here, so that would have been a capacitor. And then most likely, so a massive MOSFET or something as well. Good news, they're duplicated on both sides, so even though this guy is cracked, and I'll show you it here in a minute when I pull it apart and get it out of here, you'll be able to see exactly what we're dealing with. Yeah, let me get it apart. Okay, so make sure that is off. Pulled, that was actually the amplifier board, output amplifier for channel 2 to drive those speakers. So I pulled it out. It's now no longer in circuit. Briefly replace those fuses in there. All 4 were blown. This will not. And we're going to try to power it up without that side, because I want to see if it'll at least power on with that removed. And then fingers crossed we have no other issues on here. Of course, we'll find out quick, fast, and in a hurry if there are ones, because we'll blow more fuses. So let's see what happens. Engaging squint. Hey, there we go. It's powering on at least. No, I'm not seeing any. Probably because there's no signal coming in. Nothing is happening on that side, so ignore this. This is due to my light from my phone being on. See, they're not illuminated. But this is at minimum a good indication. That means that our issue is going to be focused around this side of our amplifier. Hopefully. And hopefully there's no audio issues as well. So back over to the bench. Well, just as a quick experimentation, I've got a 1 kHz tone generating from my cell phone going into the back over here, so I can at least check channel A and couple my probe up to my oscilloscope. So you can see that 1 kHz tone there, and as I increase, decrease, increase, you can see the amplitude going up. So at least from where the cell phone, the input voltage and the amplification of that, you know, it's about 180 millivolts at the speaker jack, somewhere around there, being amplified up to 2.2, almost 2.2 volts AC. I don't know if that's high enough, but and that's what's amplifying it up to. So let's drop this down some. 20 millivolts, fully counterclockwise. Let's bump it up. There we go. Start to get about 51 millivolts. And then it jumps up from there. I have to look at the data sheet for it to see how much it's supposed to amplify. But just off the cuff, I mean, that's a clean 1 kHz sinusoidal waveform. Not seeing any characteristics that are bad on it, so it looks pretty clean to me. I don't think there's any issue with channel A whatsoever. We'll get channel 2 or channel B repaired and go from there. I wonder if this had anything to do with that channel giving up the ghost. It's a exposed wire on the hot side. Hold on a second here. Let me drop that into there. Yeah. Black wire's death. White's your return. Green's your ground. So if this shorted out on anything, that could potentially explain why you had some things go poppy poppy, snappy snappy inside. Well, if you want to look at some carnage, Here we go. This is yeah, it's the innards of an electrolytic. So got the prongs or legs of the electrolytic, which would be soldered underneath the board. That's how they run up to all their little dielectric and insulative materials. Insulative, I said that wrong. Insulation. What am I thinking of? Words at the dark 30. Yeah, lots of carnage on that board. It's gonna have to get cleaned up now. I'll be checking these other electrolytics around it, but they, other than being dirty, you can see the smoke. I kind of rub that off. Explosions and stuff. They don't look like they're in bad shape, but we'll check them. But here's the main carnage right here. So let's zoom in. TDA 7294. TDA 7294. Let's take a look at that for a second. And here we go. TDA 7294, 100 volt, 100 watt DMOS audio amplifier. Looks like you got mute standby function built in as well. Very high operating voltage range. We will definitely be in the TDA 7294V order code. That's configuration, and I did confirm this with the other one that's still functional in the amp. Here you go. Here's some characteristics. 4 ohm highest power into both 4 ohm and 8 ohm loads. So there goes your speaker arrangement. 4 ohm or 8 ohm speakers. Internal circuitry of that amplifier there. It's like we have 2 stages. What is this, like an internal push-pull? Standby switch. See, 22 microfarad cap. Is that internal or is that external one that's blown up? You knew. Couple of 22 microfarad caps. Alright, so yeah, that would be external then, if I'm reading this correctly, because here goes our ends, our mute, standby, those are all the pins. Our mains, our regulated voltage coming in at pin 7, that's our positive rail. And wait a second, am I reading that right? Yeah, pin 7 and pin 13. So we're powering these 2 amplifiers right here. And our negative rail here on pin 8. Looks like it's... Is that pin 8? We're tied to these 2 pins. At least pin 8, pin 15 maybe. Pin 1 standby ground. Okay, so looks like you trigger a ground to pin 1 to go into standby. Output speaker 2.7 ohm, coupled to 100 nanofarad capacitor. Here's your bootstrap. Yeah, it's most likely, if I had to take a guess without digging into the circuit board, I would say that we have at least lost either C5 here or C2. Again, this is a data sheet on this this amplifier, okay, this is a typical application that you would see it in, not necessarily the application as it resides inside the our Phonic Max250. But if they use a similar arrangement, then we either lost this here or this here. Well, really, the only other thing I want to do here, and I did check these caps off camera to see if there's anything else still stored in there. Zilch, nada. I do kind of want to check these other electrolytics just to see if they're within range. Now they are in circuit, so might not get the most accurate measurement, but yeah, what was that saying? 4.7 microfarad, and this is a 4.7 microfarad cap. Huh. Okay. Well, I'm going to go around the board and compare my caps. I'm going to check diodes. Resistors look to be fine. I'll just check some things and then compare it to the other channel. And if anything interesting pops out, I'll let you know. We'll come back. But I did record down everything thus far. 250 volt, 6.3 amp fuses, need 2. I've got those. 250 volt, 3.15 amp fuses I don't have. I did use 2 additional 6.3 amps in there, so need to replace them with the 4 total fuses. Need to replace those 2 with 3.15 amp fast blow fuses. 22 millimeter, those short order fuses. I've got several 22 microfarad caps in stock, but the highest voltage I have is 35. We need to be at least 50, so going to get that in order. And 0 of these TDA 7294s, going to have to get that in order. The power cord, I do have a junk power cord in good condition. I should say spare power cord, it's not junk, but can repurpose that and get that repaired. That's no big deal. Well, everything seems to check out for the most part, except for this one diode sitting right here. Let me zoom in just a smidge for you. There we go. Might just be easier if I was to lift this up for a second, but we do have a diode here that is giving us a weird reading. Okay, should not have continuity this way. Should be reading that way. But the thing is when you follow it across the board, you're going through, not only feeding to this is tip 107, and we got tip 107, 102, 107, 102. So these are MOSFET type amplifiers here and here, but this is tied to this coil going to our blown up amp here, so it's potential that that could be reading bad because of this. Maybe. So more than likely when we replace this, I'll probably be pulling this diode out, checking it out of circuit as well, if that's not resolved. But no issue there. I've got several of these sitting in my cabinet. I'm not too concerned about it. Hopefully these MOSFETs are fine. Tip 107, tip 102. I'm going to look them up real quick. Probably gotta get this close to the camera, otherwise it washes out. See, take it away. Won't focus. The light will start washing out. But anyways, slight correction there. Yeah, Darlington transistors, no different than you know, guitar amp prior to going to your, you know, big power amplifier type IC circuit. But anyways, 102
102 is a NPN power transistor, and 107 is a PNP power transistor. So yeah, pretty simple type stuff, no different than any other audio amplifier you can come across. Kind of all the same components and stuff. May also have a short collector to emitter right here on tip 147. This is our PNP, so I need a negative on the base. That reads fine. Oh, hold on a second. Yeah, that reads fine. When I bias the base. Oh, touched the wrong thing. And then comparing, switching it over, that kind of measures similar values to the good one over in the, what you call it. But just going base collector to emitter, I'm getting a short, and that should not be that way. So we might be replacing that as well. May just do both. So tip 102 and DIP 107 Darlingtons. Again, that diode I have, so we may be doing all three there. It is quite possible that whichever one blew first, no matter, they're both gone, that we got some bad transistors too. Okay, well, something else going on. I'll check to see if I got them in stock. If not, we'll have to order them too. Well, we do have some good documentation for this amplifier. Found some the manual and schematics both online. Basic setup configuration to drive your monitors or your speakers. Looking at 60 watts max for 8 ohm, 80 watt max for 4 ohm. So that needs to be kept in consideration if you are, say, using multiple speakers on one channel output. You don't want to put your speakers in series to be above 8 ohms, or to be anything other than 8 or 4 ohms, or place your speakers in parallel, and you know, that resistance could potentially go below 4 ohms, say 2 ohms. You know, you end up blowing your speakers. But anyways, just some things to consider. Signal to noise 103 dB. That's pretty good, I would suppose. But what was the max? What are we looking at for power amplification? Gain about 30 dB. Okay, so that's right here. 30 dB gain. Okay, cool. So we at least have that data now. Sensitivity 4 dBu, 8 ohm. But I'm more concerned with that gain. And then over on our schematic side, here we go. C67. This is that 22 microfarad 50 volt cap that blew up. You can see it's tied here to the output at pin 14 and our bootstrap pin 6 for IC2, which was also completely blown up. And then we measured, looked like we had some issues with a collector to emitter short here on Q23. Oh, sorry, not Q23. Q21. That's our tip 107, which may indicate why D20, that what was that, 4148 diode. We were getting some iffy readings testing it. But what failed first? We have a collector to emitter short that started pulling too much current. This is tied to our negative voltage rail going into pin 15, pin 8 as well. So power, voltage, negative rail. Into IC2, did excessive current cause these component failures here, or vice versa? I'm going to pull IC2 off the circuit board and check again. Going back over here, I've removed out IC2. You see it's no longer populated on the board. And so let's check Q21 now. 26. It's going to an open, so that's now testing good. We don't have a short anymore, collector to emitter. This should be, oh, touching the wrong thing there. This should be open. And 0.9. Yes, that's fine. Let's check it out good. That's exactly what we've got on the other board. I'm sure if I removed it, it tests fine. And our diode is now reading as it should. Gotten a little bit congested since last started recording, so I apologize if I sound a bit snuffy here. But yeah, with the IC2 removed, tip 107 now tests fine, and so does or Q21, and so does D21. However, I'm still iffy on keeping that in, especially because it was, when IC2 went out, most likely that caused the collector to emitter short. But if that was the state of Q21, if it was biased in that way, shorted between collector and emitter, that could not have been good for the operation of this Darlington transistor. So I would suspect that it could be a potential near future failure. Could be wrong, but we're going to still replace that anyways. So let me get C67 replaced, IC2 and tip 107. I'm going to run this by the owner and see what the owner has to say, and give them my thoughts, and we'll see what they come back with. Okay, and we were able to get some parts on order. Here goes the IC amp. DigiKey had them in stock, so we have this packaged and we can get that installed. I had the diodes, but I didn't. Here goes tip 107. Ordered one of those. Had to order 22 microfarad 50 volt caps. Fortunately, didn't have any of those in stock. And then some 3.15 amp fuses, because the ones I'd stuck in there to fit into those sockets were 6.3 amp fuses. So got those fuses on order as well, all from DigiKey. Total came to about $35 in parts. Customer was happy, especially because the vendor he goes to for buying amplifiers had given them a quote of around $700 or something for a new amp. So parts and everything, and kicked over invoice. Customer is happy, so we'll proceed with the repair and get these components in here, and then these spares, I'll just see if he wants spare capacitors, spare fuses, or what he wants to do with them. And if he decides he don't want them, then cool, I can keep these for a future repair. But good savings for him. Tested if I didn't mention it, tested the other caps and everything. They all seem to be fine. Transistors seem to be fine. So, excuse me. We'll get these components replaced and get it put back in there. Check a few voltages after we power it up on the on the dim bulb tester and check the amplification. Make sure everything is good to go. since everything's been replaced on here. We'll see how that goes. So far so good, and let's quit. Hey, all good so far. I'm gonna check some voltages on the our different PCBs there. Okay, so let's check some of our operational voltages. Should be negative 40 on this side if I can get a good ground. Let's see. There we go. And negative 46. Let's see what. Positive 46. Negative 28. Positive 28. Should be that on both sides of this plug, so yeah. Good there. Are we developing our 12 volt? Should be 12 volts here. We are. Yep. Alright, so that looks good. And here goes our 27 or 30 or whatever you want to call it. And 12. Okay. Well, let's see. What do we got them over here? Yeah, 27. 12. 30 and 12. Alright. So, looks like we're getting all of our correct voltages. Let's do a test tone, see what we get. Again, pretty straightforward and simple setup. 1 kHz tone coming out of my signal generator, 4 volts peak to peak. Got that coming out over some alligator clips going to basically guitar cable, audio cable, into channel 1 on the back, and channel 1 output going up to my oscilloscope. And we can see right here with a 4 volt peak to peak input, and as I adjust channel 1, we get an output of 55.2.6. That waveform looks pretty good. So that comes out to what, about 22 dB of gain versus the what was mentioned on the manual, 30 dB or whatever. Let's check channel 2. Unplug this here. Plug this in over here. And unhook that. And this guy, let's go over to channel 2. See what we get. That should be on. Alright, channel 2 in, and it's pretty waveform. Amplifier's working, and 56.4, so slightly more amplification. Let's plug that in. Let's call it an even 56. So still looking at 22, 23 dB of gain. Alright, I'm good with that. Our amplifier is looking good. Input, V, output. So, any lessons learned? Well, I'll turn on. Obviously, overdid it a bit in the thermal grease I applied. It is what it is. I had a bit of difficulty with IC2 there. Some of the pads weren't in the best condition. either because of how I removed it or because of how it imploded. But I was able to, if I had a paste kit, could have done some new eyelets in there, no big deal. But I ended up just going to the backside chip, which is why I had to take this heat sink off and then bridge the connections between the legs of the IC to their points, to the remaining of the pads on the printed circuit board. So it worked out just fine, and just made sure that everything was nothing was shorted out, etc. Something worthy to note: when you are installing ICs that are mounted on a heatsink, such as this with these screws, etc., right? If you notice these plastic little thin wafer sheets behind them, that is to ensure that that you're isolated between the metal portion of your Darlington transistor amplifier, and that's not touching metal over here, because that presents a short. As a matter of fact, you notice like these screws have those white washers that kind of run the length of the screw. That way you're isolated between the screw and the inside diameter of the hole that you screw into. Additionally, here's something else you should consider, because these things you need to make sure that you have in there. You're not going to replace it without those, otherwise you're going to short out your devices, your components. Another thing to consider, all right, when you replace these type of components, okay, you don't solder them in and then screw them in, because that puts strain on the legs of your component. What you do is you screw it in, you put it down through the holes, you screw it in, and then you solder. That's what I practice for both of these. And by doing so, there is no strain on the leg, so you don't have any premature failures from where, say, thermocycling or something like that, the legs heat up, the soldering starts to crack, or something along those lines. Ended up not replacing the entire power cord, just cut back the section that was bad, and rewired it up and soldered those wires together, so that should last for a pretty long time. And took out the 6.3 volt or 6.3 amp fuses that were in the 3.15 amp slots, 250 volt. Yeah, and put the right fuses in there. So that's all good, and everything seems to be working just fine. So I was trying to think of the best way I could demonstrate a test of this with actual audio playing. So what I did is I just alligator clipped the channel 1 output to my guitar speaker, amp speaker sitting there. Then got 1K or so going into channel 1. Yeah, that's low level audio, so the signal doesn't turn on until you increase it up to that point. Well, there goes channel 1. And let's unplug this, put that into channel 2, and let's see what we get on channel 2. Oh, here we go. Channel 2. Same thing, low level audio. But hey, there you go. For those of you that need to hear the audio and not just see it, it is worky. Well, there you have it, folks. Pretty simple repair. Not a whole lot that went into this one. And was able to absolutely save the customer quite a bit of money on this repair. They didn't have to buy a brand new item, which again, they were quoted something around like $700. And then the eBay purchase was what, 80 to 180 or whatever it was, and we came in way below that. But anyways, Appreciate you watching. If you enjoyed this video, please give it a thumbs up. Consider subscribing as well if you're enjoying the content. If you have an item that you need repaired, please see the business side link in the description, take you to the Google site. If you're local, you can just drop off with me, we'll meet up. If not, just ship your device in. And if you're inclined to donate, you can do that too, PayPal in the description. But that's going to do it for this Phonic Max250. Hopefully you enjoyed watching this video. Take care. Goodbye.
Bark.